everyone, welcome you all to yet another session on automotive technologies, and this session is about electric vehicles. So without any delay, let me walk you through the topics which we will be talking today. We will begin by discussion what exactly is electric vehicles, and then I will take you through electric vehicle goals, history of electric vehicle, what are the different EV components. Here we will talk about the batteries, charging systems. Then we will talk about the V controller, how electric vehicle works, challenges in electric vehicle, and finally we will also talk about the future trends in EV technology. So let's start with electric vehicles goals. If you see this figure, this clearly shows that if we are using the conventional vehicle or diesel or petrol vehicle, definitely it adds the pollution. And pollution is the largest environmental cause of disease and premature death. Pollution causes more than 9 million premature deaths, the majority of them due to the air pollution. Since the engines are consuming fuel and air and create heat in the consumption process, nitrogen from the air can be transported into the nitrogen oxide, which are reddish brown gases that irritates the lungs and eyes. If you see on this side, if the vehicle or while vehicle is in motion, vehicle must emit no carbon dioxide or any other pollutant. This is been expected. And throughout a global, it is expected we should go green. So electric vehicles are what item into the auto world, and this is a new technology, and everyone expect this transition from the conventional vehicle. We are expecting this transition to the go green on the greener planet. So what are the goals? As I told earlier, electric vehicles are a new technology, hot item into the automotive world, with many auto manufacturers offering at least one model. Improved versions are on the near horizon for a good reason. Electric vehicles provide environmental advantage, and even though they may carry a higher price tag initially, tax credits and lower operating costs often balance out the initial investment. Fewer carbon monoxide emissions through the increased efficiency, greenhouse gas emission contributes to the global warming. Use of electric vehicle would help reduce emissions, and that is the environmental advantage. The second point is very important, that is the zero carbon emission. As we know, the electric vehicles are powered by electricity rather than any fuel, which means that they does not produce any carbon emission. Carbon contributes to the greenhouse effect and is known as the most important long-lived forcing of climate change. The global warming. The greenhouse effect is when the atmosphere dioxide traps heat, which leads to an increase in the atmosphere or the temperature of the surface. High air pollution levels negatively affect the public health. Vehicles that burn conventional fuel creates the emission that adds to this level. Electric vehicles produces fewer emissions. Some produce no emissions at all, and lower emissions is equal to the improved air quality. What are the economical benefits? Electric vehicle reduces the fuel cost for consumers. Advanced vehicle component sector employs the globalization. World locally approved policies to get the better incentives help reduce the initial purchase prices of the electric vehicle. So indirectly or directly, all these points definitely leads toward the economical benefits. Electrification enables us to decrease the use of fossil fuel and creates a better city life by reducing noise and improving air quality. The last and very important point is minimizing the noise pollution in urban areas, reducing the carbon emissions, decreasing the operating cost, and lowering dependence on fossil fuel. These are the goals of electric vehicles. Now moving to the topic, that is the history of electric vehicle. So between 1832 and 1839, Scottish inventor Robert Anderson invented a crude electric carriage. And here are some images. And he is a Scottish inventor, Robert, and here is his invention, that is electric carriage. So it started in 1832 and around 18 in between the 1832 and 1839. The other end, in 1835, Professor Sibrandus Strati of Groningen, Netherlands, and his assistant Christopher Becker from Germany also created a small-scale electric car powered by no rechargeable primary cells. And here are some images. So both this, they invented this in the 1835. Sibrandus and Christopher both were contributed, and they created a small-scale electric car. And here is the image. Now, it is really hard to pinpoint the invention of electric car to one inventor or country. Instead, it was a series of breakthroughs from the battery to electric motors in early 18th century, and that leads to the electric vehicle on the road. So it was Henry Ford's mass-produced Model T that dealt below the electric car. By that time, the gasoline car cost was around $650 and the electric cost was around $1,700. The price of electric vehicle was almost three times higher, but the Henry Ford took that risk and the Model T, that was a part of electric car, and it was around 18th century. In India, the concept of electric vehicle was unveiled under the National Electric Mobility Mission Plan 2020. So So it was in the 2013 to address the national issues of the energy security and the vehicle pollution. And that mission was called National Electric Mobility Mission Plan 2020. In 1888, what is considered to be a first electric car appeared in the Germany. The Flocken Electrowagen invented by the inventor and entrepreneur named Andreas Flocken. Around 1889 and 1890, when William Morrison from the Des Moines Iowa created the first successful electric vehicle in the United States. His car is a little more than the electrified wagon, but it sparks an interest in the electric vehicle. In 2001, the first ever electric car Reva was launched in India by Reva Electric Car Company, known as Mahindra Electric. So this is all about the history behind the electric vehicle. And as I started with the first point, that it is very hard to pinpoint the invention of electric car to one inventor or specific country, but the journey started around 1800. What are the different electric vehicle components? So electric vehicle charging system is one of the major and important component. Second component is the battery management system and the lithium-ion battery, traction motor and the traction inverter, auxiliary inverter, which are used for power steering application as well as for the pneumatic applications. DC-DC converter, power distribution unit, which delivers the power to all critical traction and auxiliary loads while protecting electronic components and the vehicle occupants. So usually this PDU consists of a pre-charging as well as the fuses and all, everything is included under this power distribution unit. And as a name indicate, it distributes the power from the battery to the different loads. Now, the last component, that is the electric vehicle controller, or sometimes it is referred as a vehicle controller, which controls the entire vehicle. And equally important, coolant systems, which includes the oil pump, radiator, everything is a part of this coolant system, but it is required. If the power rating of the electric vehicle are in kilowatts, then we usually rely on liquid cooled coolant systems. Now, EV charging systems. If you see this image carefully, we can clearly figure out there are two types of chargings. One is a DC charging that is a DC charging station, and another is a AC charging station. So many times we call this is a EVSE. EVSE is a electric vehicle supply equipment. So electric vehicle supply equipment controls the transfer of electricity from the local power supply to an electric vehicle. So its batteries can recharge safely and efficiently. While electric vehicle supply equipment is the industry technical term, common and very acceptable names used for the EVSE includes the EV charger, sometimes you call as a charging station, sometimes we call it as charge points or charging docks. So this is called as EVSE basically. We refer as this is an electric vehicle supply equipment or the charging station or the charging point. Now when I say onboard charging, then we take the power from the AC charging point, and that AC charging point takes the power through the connectors to the vehicle, and here is the one ECU that is called onboard charger. So these onboard chargers take the AC power and convert that into the DC, as well as it getting controlled by the electric vehicle controller to regulate the charging current as well as the charging voltage. So when you want to run the charging or the charge the batteries in the constant voltage or constant current, the rate of current as well as the rate of voltage is controlled by this onboard chargers, which is commanded by the electric vehicle. So onboard charger is one of the important component. If we are using the AC charging point, then we need to use this onboard charger inside the vehicle to charge the batteries. So it takes the power AC, convert that into the DC in the regulated form of controlled current as well as controlled voltage and feed that to the high voltage batteries, lithium-ion batteries, and batteries get charged. So this is the onboard charging system. And there is another charging system that is the wireless charging. And how the wireless charging system works actually. Wireless charging of electric vehicle relies on the resonant magnetic induction to the transfer energy between the charging pad in the floor and another pad on the underside of the vehicle. So here you can see here is the charging pad. So and the other end is installed in the vehicle. And because of the resonant magnetic induction, the energy get transferred from the power line to the vehicle to charge the batteries. This could include the highway sections with the embedded charging transmitters that charge the batteries of passing vehicles while driving. What are the different types of the charging? So level 1 charging. When I say level 1, this type of charging, there are several form factors of EVSE housing, ranging from a box on the cable itself to a enclosure mounted a wall or pedestrian to the tower you see at the public charging locations. The box on a cable is preliminarily used for the home charging. Wall and pedestrian mounted devices can be for a home, multifamily residential, workplaces, fleet, hotel, retail, and the public chargers. This is a dedicated 120 volt circuit standard outlet based for the shorter commutes, that is 30 to 40 miles per day, and expect the longer charging time. So this is a level 1 charging. Then the second type is a level 2 charging. Here the charging for electric vehicle is rated at 240 volt. Additional hardware is required for this type of charging. On the purchase of an electric vehicle, some manufacturers will install an AC wall box charger at the customer's home, and in some cases the place of work as well, either free of cost or otherwise, in order to enable level 2 charging. With the use of this, the electric vehicles can be fully charged in the early of 6 hours or little over, depending upon the battery capacity. And the third type is level 3 charging. It works on high power, public only, and it charges up to 80% in 30 minutes. And then it starts slowly charge to protect the batteries. Best for quick charging on the roads. The next type of charging is the wireless charging. Wireless charging, also known as induction charging, does not require a fixed physical connection between the charging facility and the vehicle. Instead, the system creates a localized electromagnetic field around the charging pad, which is activated when the electric vehicle with the corresponding pad is positioned above it. The wireless method currently operates at only a selected few pilot locations and is yet to be used commercially. Wireless charging also requires an additional charger to be integrated into the vehicle, which increases the vehicle cost. So these are the types of charging systems. And the last technology, we also articulate this inside the types of charging, but basically it's not a type of charging, but it is a technology falls under the charging, that is the battery swapping technology. Here, usually we replace the battery from the vehicle and uses the another battery which are already charged in the charging station with a lower temperature as well as the low current range to increase the life of the battery. And we swap that battery inside the vehicle and uses the vehicle. Now lithium-ion battery. So this is another important component in the vehicle, in the electric vehicle. While the battery is discharging, how it works actually. If your if battery is getting discharged and providing the electric current, the anode releases the lithium ions to cathode. So you can clearly see here the anode are releasing um, lithium ions to the cathode, and which generates the electric flow of electrons from one side to the other side. When plugging into the device, or if we are plugging for the charging, the opposite happens. The lithium ion are released by the cathode and received by the anode. And this is clearly visible here, what happens during the charging as well as what happens during the discharging. Everything is clearly visible here, how the ions are released and how the ions are attracted to the other end. So lithium ion batteries, they also have the high power to weight ratio, high energy efficiency, good high temperature performance, long life, and low self-discharge. Most components of the lithium-ion batteries can be recycled, but the cost of the material recovery remains a challenge for the industry. Lithium-ion, that is LiNMC battery, nickel metal carbide batteries using lithium nickel manganese cobalt oxides are the most common in EV. When I say LiNMC, lithium NMC, that is a lithium, nickel, manganese, cobalt oxide. This is the chemistry used in the lithium ion. Of all the various types of the lithium ion batteries, three cell chemistry types emerges as widely used in on and off highway electric vehicles. The first one is a lithium ferrophosphate or lithium iron phosphate LFP. Second one is a lithium nickel manganese cobalt oxide, that is NMC. And the third one is, and the last one is a lithium nickel cobalt aluminum oxide, that is NCA. Lithium batteries provides 85% to 100% of their stored capacity, regardless of the rate of discharge. On the other hand, the lead acid batteries typically provides less usable energy with a higher rate of discharge, closest to 50% only. Lead acid batteries are cheaper and are easier to install when compared to the lithium ion batteries, because lithium ion batteries are costlier because of the material required to form the lithium ion batteries, and it is required a higher complexity to control the batteries. Now, why we need a battery management system? Battery management system basically is integrated with connected to the lithium ion battery pack. Lithium ion battery pack is made from the cell. Cells are connected in series and parallel. The way it is required, the configuration. When we connect cells in parallel, that means we expect a higher energy or higher capacity. When we connect the cells in series, then we expect the higher voltage. Based on the need of the operating voltage and the ampere hour capacity in the battery, usually the batteries are connected or made from the series and parallel combination of the cells, and this is visible here. But if you see carefully, during the charging, or during the discharge, it is clearly visible that few of the cells are getting initially charged or not fully charged, right? And few of the cells are overcharged, right? So here it is clearly visible or over discharge. So here also you can see that the normal it is fully charged, and in the overcharged the cells get heated, or undercharged that means the cell is not even charged or fully discharged or fully drained. So to avoid this, we need to have the controller to monitor individual cell and control the charging and discharging current out of that. And that is done by the battery management system. So battery management system is a controller which manages all the operations of the cells at cell level for the entire battery pack. So not only for the cell voltage, it also protects overcharging, also protects the thermal behavior of individual cells and increases the life of the cell. So as increase the life of the entire battery pack. Here you can see the thermal behavior also. If we see here at this side, the coolant is reaching at the beginning and the same heated coolant going through this entire pack so that these cells are heated up. So what happens throughout the life, this cell gets damaged early. So we ideally should not use these cells very frequently to save the life of the battery. For that, we need to monitor these cells, right? And we also monitor these cells. And accordingly, we need to fetch the current or charge the cells with the limited current to save the life. And that is done by the BMS. BMS individually monitor the each cell and accordingly control its charging and discharging current. And that is the need of the BMS. So here how it is integrated. In the most of the application, this we call it as a module. And then the module formulates the entire battery pack. Normally for each model, we uses one battery management system and that called as slave board. And all these slave boards are communicated to the master board. So it is purely dependent. If manufacturer wanted to keep the watch on the individual cells or monitor or the manufacturer want to keep a watch on the module level, it is up to the need basically. So what is the operations of the BMS? BMS protect the current, monitor the current, it's also monitor the voltage, temperature, it takes care of the all communications, whatever the commands it is getting from the vehicle controller, and it sends the information of the cell temperature, um, state of health, state of charge, all thermal information, power optimization, and to display all the status, whatever the happening inside the cells or the battery level or the pack level, that is the voltage, current, everything, charging current, charging, discharging, every information can be displayed. So everything is done by this battery management system, and it is wired and connected to this battery pack through the slave boards which are connected to each module, and that each module communicate to the master board, and that is the BMS. Even the small board also called as a BMS, but they are the slave boards. Typically they gather the information from the sensors and form the CAN frame and communicate to this master board, or sometime wirely connected to the master board, that is the BMS. So this is how the battery management system and BMS are interconnected. What is the working principle of electric vehicle? It is very simple. If you follow my previous knowledge sharing sessions, here I explained the hybrid vehicle technologies and operations of the vehicle. But if we compare the operation of electric vehicle, it's very straightforward because here the only one power source is there, and that power source is the battery power source. And the battery feeds the power to the electric machine. These are the different components plays very important role. The battery fed the power to the power distribution unit, and here the precharging happens. Sometimes the precharging happens at the battery end as well to avoid the effect of the surge current. Then the power distribution unit distribute the power to the DC-DC converter, and the DC-DC converter convert that high voltage of this entire pack to the low voltage required for this LV battery in the vehicle, as well as the power required or the voltage required for the different ECUs in the vehicle. That job is done by the DC-DC converter. And if the DC-DC converter is not capable to convert the high voltage to the 12 volt or 24 volt, then again we use the another DC-DC converter. Like if this is converting into the 24 volt, if it is a high I mean the commercial vehicle or the buses, then it converts the 24 volt. And then again, we use the 24 volt to 12 volt or the 5 volt based on the need of the sensors or the ECUs. But the major use of high level use of the DC-DC converter to convert the high voltage, convert that low voltage and charge the batteries into the vehicle, as well as provide the power to the LV power to the different ECUs present into the vehicle. Then this on the same connection from this power distribution unit, the auxiliary inverters are connected, which are controlled by this AV controller. AV controller sends the command over a CAN to operate accordingly. And here is the motor, which are controlled by this switching frequencies by this inverter, and then it controls the electric power steering pump as well as it can be used for as an electric power pump, or the same can be used for the pneumatic systems to fill the master air tank. And then the same way, on the other hand, once the batteries are connected, once the vehicle control detects the driver is demanding some power, accordingly, uh, it sends the command to the inverter to generate specific torque or speed. And it takes the power from this power distribution unit, and you, with the help of switching technology, switching frequency, it's it asks the motor to generate the specific torque and speed, and the vehicle get propelled or the vehicle get driven. This is a very simple operation of the electric vehicle. Entire control strategies is written inside the electric vehicle controller, or sometimes referred as a vehicle controller. And this is the battery pack, feeds the power to PDU. From the PDU, it goes to inverter, and from the inverter to the traction motor to drive the vehicle. This is working principle of electric vehicle. Now, what are the electric vehicle challenges? There are so many challenges also around this technology. So charging infrastructure. One of the most significant challenges in the electric vehicle sector is the lack of widespread and efficient charging stations or charging infrastructure. The second challenge is the cost. The cost of electric vehicle components such as the batteries and electric motors is currently higher than that of the conventional fuel engine. The range anxiety, the term commonly used to explain the anxiety that the electric vehicle owners to or the drivers may feel regarding the distance their vehicle may be travel. Next challenge is the infrastructure. The challenges in energy infrastructure for the electric vehicle includes the need of efficient charging infrastructure and energy resources. The consumer readiness, lack of predictability makes it hard for the average consumer to put their faith in such a significant purchase. And that is the reason there is a not a readiness around the consumer. It is a challenge for the automotive industries. Cost of electricity. The other challenge include the lack of charging stations, the long charging time, and the high cost of electric vehicles. Lack of standardization. Electric vehicle technology poses a challenge for the industry, and different manufacturers adopt the different standard. And this is one of the major challenge which falls under the electric vehicle. Safe and efficient EV transportation. One of the most significant challenge in the electric vehicle sector is the lack of widespread and efficient charging infrastructure. Apart from these, the other challenges are there, and that are like reliance on battery imports, supply chains, battery technologies, charging time, deal with the electric vehicle design differently, demand charges, driving range of electric vehicle, lack of charging stations, and lack of clean energy. So these are all are the electric vehicle challenges. But as the technology is moving, as we are expecting the green planet, go green is the expectation from the world. Definitely, world is looking for the challenges, whatever that mitigate these challenges. Now, what is the future trend on the electric vehicle technologies? First is a charging infrastructure development. As we talked on the challenges, at the same time, these are the future trends which are mitigating our um, challenges. So charging infrastructure development. Currently, the charging market globally is highly fragmented with different charging standards. So advancement in the battery technology. Innovations in battery technology plays a key role in the electric vehicle market. Advancements in the lithium-ion batteries have reduced EV battery cost by approximately 90%. As battery technology continues to improve, EVs will become even more efficient and affordable. And as I explained, there are different chemistries are being tried so that the cost of the battery will get reduced. And that falls under this advancement in the battery technologies. We expect faster EV charging. Sometimes it has been expected 20 times faster EV charging. So consumer demands for longer range per charge and faster charging times are leading to the EV power system that must operate at a higher voltage and temperature. As we expect the higher voltage, higher current and the higher temperature, as higher current, definitely there is a higher thermal losses and that is a higher temperature. And of course, it may lead toward the lesser life of the battery. So this is one of the trend and the technology where the entire globe is working fast charging technology. How we can fastly charge the batteries with the lesser thermal effect and the lesser other disadvantage of that is leading toward the life of the battery. So the next is autonomous driving. Robust testing and safety standard for autonomous driving is required. The rigorous testing is required to ensure the safe driving experience, especially for ADAS, advanced sensory technology, shared mobility, EV and the battery recycling processes. Everything is mutually linked to each other, and the ADAS is one of them. That is the autonomous driving technology is also a future trend or the currently trending technology in the electric vehicle. Smart charging. One of the most promising trend in the EV charging is the integration of smart charging solutions. As the demands of electric cars rises, so does the necessity for the efficient charging infrastructure. Smart grids. Smart grids enhance the EV charging efficiency and improve the load balancing, ensuring the smooth charging experiences for the user. Fuel cell technologies. Along with solar, wind, and hydro, there has been a growing interest in the hydrogen fuel cell technology. Shared mobility and battery recycling and reuse technologies will greatly benefit the EV stakeholder and the future promote EV adoption. Apart from this, there are other future trends around this EV technology are the acceleration and acceleration to the EV innovation, improved infrastructure, and so on. So, and this is the end for your learning today, and that's enough for the today. If you like this knowledge session, then please be kind enough to like and share my video. If you are new to my channel, do not forget to subscribe. I would also like to know always what was valuable for you inside this session, and I'm really making something interesting for your learning. What was your most valuable takeaway from this session? Tell me in the comment box for the chance to be my next viewer of the week. I'll see you in the next one. Thank you for your time and have a nice day ahead.